In this lecture, I am going to explain abrasive jet machining. The aim of this session is to familiarize the students with abrasive jet machining. The instructional objectives. This session is designed to understand the working principle of abrasive jet machining, know about applications of abrasive jet machining. Learning outcomes. After the end of the session, students are able to understand the working principle of abrasive jet machining and clear about merits and demerits of abrasive jet machining. Now let us see that abrasive jet machining. The abrasive jet machining is a non-traditional machining process that utilizes a high-speed jet of abrasive particles mixed with a gas or air to remove material from the workpiece. It is often used for precise cutting, cleaning and surface preparation of hard and brittle materials. In abrasive jet machining, the abrasive particles act as the cutting tool. These particles are typically made of materials like aluminum oxide, silicon carbide or diamond. The basic setup of an abrasive jet machining system includes a mixing chamber, a nozzle and a control system. The mixing chamber is where the abrasive particles are mixed with the gas or air to form a high velocity abrasive jet. The nozzle directs the jet towards the workpiece and the control system regulates the pressure and flow rate of the abrasive mixture. The high speed jet of abrasive particles impacts the workpiece surface, causing erosion and removal of material through micro cutting and brittle fracture. Now let us see that the setup of the abrasive jet machining. Here the gas supply, the gas is supplied through the stored cylinder and there is a regulator valve and there is a filter. Through the filters the gas is entered and here you can regulate the pressure of the gas, and this is the chamber that where the powder is mixed with the gas, okay, and this entire in the bottom we are providing the vibrator to evenly mix the powder particles, the abrasive particles with the used gas, and that high pressured mixer will enter through this pipeline, and here you can operate this valve through foot, that is a foot control valve, and with the foot control valve you can operate this abrasive jet, that is a that passing through this nozzle, and here we are providing the hand holder. You can hold this nozzle and the nozzle is directing on the workpiece and the jet is impact on the workpiece, and due to this high impact of this abrasive jet the material is comes out, and here providing the shield of without any flashing this material to the outside the environment. You can protect that with the help of some hood shield you are provided, and whatever the gases are liberated, generated, that can escape through this exhaust pipe. This is the main the setup is used in abrasive jet machining. Now let us see that abrasive jet machining working principle. The working principle of abrasive jet machining involves the following steps. One is generation of abrasive jet. Just now watched that setup how we can generate the abrasive jet. Abrasive jet is created by mixing abrasive particles with a carrier gas. The gas and abrasive mixture are passed through a nozzle or a specially designed tool called an abrasive jet nozzle. So acceleration of abrasive particles. The mixture of gas and abrasive particles passes through the nozzle which narrows down the cross-sectional area. This leads to an increase in gas velocity and acceleration of the abrasive particles. The velocity of the abrasive particles can reach several hundred meters per second. So the directing the abrasive jet. The high velocity abrasive jet is directed towards the workpiece surface and needs to be machined. The nozzle is positioned at a specific distance from the workpiece, and the direction and movement of the nozzle determine the machining path. Material removal. When the abrasive particles strike the workpiece surface, they extract efforts and cause the removal of material through the erosion. The kinetic energy of the abrasive particles is converted into mechanical energy, which results in the removal of small chips or fine particles from the workpiece surface. The erosion process is similar to sand blasting, but with much higher velocities and smaller abrasive particles. Controlling parameters. Various parameters can be controlled to optimize the machining process. These include the type and size of abrasive particles, gas pressure, nozzle diameter, standoff distance between the nozzle and workpiece, traverse rate of the nozzle, and the angle of impingement of the abrasive jet. Removal of debris. During the machining process, the removed material and abrasive particles form a mixture called slurry or abrasive laden fluid. This mixture is typically collected and separated from the gas stream using a suction system or a filter. What are the main applications of abrasive jet machining? That you can see that deburring and edge finishing is the main application of this abrasive jet machining, and micro machining. You can machine the micro, and surface cleaning and preparation. Wherever the surfaces are, we need to clean and prepare for further operations, then you can use this abrasive jet machining to clean the surfaces and prepare the workpiece for further work. Then cutting and shaping hard materials. Very hard material you can easy to cut using abrasive jet machining. Drilling and hole machining. You can make the drill and hole for hard materials, that can be possible using the abrasive jet machining. And etching and engraving. That etching and engraving operations also possible with this abrasive jet machining. Aerospace and automotive industries frequently they are used this abrasive jet machining. And restoration and conservations also that one of the application. And electronics manufacturing. In electronic field also we are using these abrasive jet machining operations. And medical and dental applications also there is a wide applications of abrasive jet machining. So these are the few 10 applications are quoted, not these other applications also there, but some of the few applications are mentioned in this session. Next, abrasive jet machining, what are the merits and demerits also you can able to know. So what are the merits? First we will see that this is the non-thermal process. There is no thermal acting of these places and no mechanical forces. Here the abrasive jet is contacting, impinging on the workpiece. There is no direct contact of the nozzle and workpiece, so there is no mechanical forces are acting. And ability to machine complex shape of the objects you can able to machine. And wide material compatibility, this can be used to the several the lot materials, all materials are compatibility will be there. Then the minimal tool wear. Tool wear is very minimum because there is no direct contact of the tool and workpiece. Surface finish and cleanliness is achieved. You can obtain the acceptable surface finish and cleanliness of the surface. That is the one merit of this abrasive jet machining. Then environmental friendliness. There is no the pollution of environment where we are working this abrasive jet machining. And flexibility and adaptability. It's flexible and adaptable any type of environment and any type of material you can machine using this abrasive jet machining. So these are the few the merits of abrasive jet machining. Now you can see that demerits also. Everything having some merits and demerits. Now you can see that what are the demerits of abrasive jet machining. First one is slow material removal rate. So material removal rate is very slow. It will take lot time to finish the required machining of the component. The limited material thickness. The thickness is also limited. Not all thickness materials are suitable for machining the abrasive jet machining. Then surface integrity and roughness control. So the surface integrity and roughness control is somewhat not acceptable. That is one limitation of this abrasive jet machining. Next, restricted depth control. The depth control also restricted. It's not going the in depth. Up to certain depth you can able to do it, and after that it's not possible. That is the one demerit of this application. Next, limited accuracy in certain applications. Its accuracy is limited. Then noise and dust generation. So there is a lot of noise and dust will be generated. For that we are providing some shield and operating the machining. And equipment complexity and maintenance. So maintenance is somewhat complexity for this abrasive jet machining setup. And abrasive particle selection and disposal is also one of the typical tasks. So these are the all related to the abrasive jet machining. So in this session I hope everyone understand what is the working principle of abrasive jet machining, and what are the setup used in the abrasive jet machining, what are the different applications of abrasive jet machining, and what are the merits and demerits that we have seen. I hope everyone understand abrasive jet machining.